recording in.
So it's recording. All right, so today we're going to talk about transformers. Okay, so the plan, or let's just say for the rest of the semester, we're going to finish up transformers. In particular, we're going to look at fine-tuning in more detail. And we're going to look at all, most, let's say, applications. That is to say, what do you use transformers for? What are specific problems that you will tackle? And then we're going to motivate all of that by you having a project that is transformer related. Now, keep in mind, transformers, there's new research going on that is actually applying them now to image processing. And some people are saying that they can be as good as CNNs. So could they be better than CNNs? Are CNNs, will transformers replace CNNs just like they replace recurrent neural networks? That's still to be decided, right? So people like Jean LeCun, who is the best known for CNNs, I would argue that CNNs are just as good as transformers, but it's literally right now, it's literally like the battle is being fought, right now in real time. And so it's really not clear who's going to win, but you can see why this semester I'm spending so much time on the transformers because, as I stated, they came out in 2017, and they were mainly applied to natural language processing with a lot of success. Basically, they made RNNs to the point where I'm not covering RNNs in my courses anymore, which was a topic that I used to cover. So there's that. And now they're being applied to vision, which is image processing. So it brings into question what's going to happen to CNN. So you can see I'm still going to cover CNNs this semester, but only towards the end. And we've already covered it with Fast AI, as I said. This, however, is there's still a battle, right? The battle, it's like, if you want to think of it, right? So they're like duking it out right now. Transformers versus CNNs. So let's see who wins. Okay, but these are being implemented. So, and hopefully towards the end of the class, I will be able to find some papers related to transformers applied to image processing and see where that is currently, okay? But anyway, so the focus, at least for the next 2 weeks, will be on transformers, and I also want you guys to do your project based on that. So I will motivate that project today. I'm gonna give you a specific problem, okay? So I'm gonna give you a specific problem. You're going to need, for that problem, to solve that problem, you will need a pre-trained transformer, you will need fine-tuning, and you will need to figure out a specific application to use. That is why today I'm going to cover that, right? So those ideas of that. So I'm gonna give you the problem. And then towards the end of the semester, as I said, we're gonna go back to vision and just lay out CNNs, lay out transformers, for vision, and maybe draw some comparisons, etc. See what's going on. Okay, I think there's probably similarities between these two. Okay, and so as far as what you have left, just remember you have the homework, converting GPT-2 to PyTorch, and then you'll have the project. And that'll be it for me in the semester, okay? So before I continue with this, are there any questions about anything? No questions? All right, so one more thing I want to point out is I had told you that I was going to post a document about transformers. And Jason reminded me that I had forgotten to add the link, so I did add the link eventually. And I just want to show you where that is. All right, let me share Brightspace. All right, so you should be seeing Brightspace now. If I click on this, you'll see, go to content. And this module, Transformers Theory. If you click on it, this is basically the PDF of the book, kind of wrote for the course. You don't have to read the whole thing, okay? You can just look at the table of contents. Let's take a look at that actually. Just to kind of illustrate the topics in deep learning. Basically, this is just intro, traditional machine learning, some of the basics. Here, deep learning goes in, it's being introduced. This is kind of what I covered in 520. And then after that, we get into the individual topics like semantic vector spaces, word-to-vec, convolutional neural networks, which is, as I said, I will cover a little bit of the theory of this. Recurrent neural networks, which, as I said, I'm no longer covering because they've been displaced by transformers. GANs, it's an advanced topic, so I will not cover it. Reinforcement learning was covered in 520. And here we have the Transformers chapter. So really, this is the chapter that you should read, okay? However, I will stress that you should also read chapter 1 if you feel that you're not, if you want to practice, let's say, a little bit of NumPy arrays, tensors, and linear algebra. So Transformers actually requires a lot of that, okay? Transformers are a very complex algorithm. I want to stress, they're the most complex, deepest algorithm I have seen in deep learning, at least in my opinion. The videos that I did before spring break, those are basically my overview of transformers. I will not go into any more detail about the general encoder-decoder with multi-head attention, the original 2017 transformer. So I'm not going to go, those videos are basically, I covered the main ideas. However, if you want to learn more, let's say everything about that particular algorithm, not all transformers, mind you, not BERT, not Roberta, not Albert, not BART, or GPT-2, GPT-3. Those are extensions of the original idea or modifications of the original idea. But this, here in this book, what you will find is just an explanation of the original one. But I think it's a fundamental one, right? You want to start at the beginning so that you can understand the other one. So maybe later in the semester, I will go over the other ones like BERT, Roberta, etc. So that's a possibility if time permits. However, as I said, it will just be an overview of it, right? Not all the details. Because if you want to understand all the details, you're really, my suggestion is read through this document. This is my best effort at explaining everything at a very low level, all right? So, basically every little detail. So I would recommend, however, that you do section 1.3 here, all right, which is about 42 pages, and it's just 42 pages of exercises, okay, on NumPy arrays. So if you don't feel like you've practiced a lot in the past and you want to practice a little bit more, go through these exercises, right? They're exercises on NumPy, they're exercises on tensors. What's great about it is that they're very consistent, right? And this will give you, it's like a good warm-up, right? To be familiar with the techniques. Does this make sense, guys? Questions so far? Okay, great. So that seems like you're understanding. And then, so let's go back to the book. So definitely, what I'm saying is you don't have to read every chapter, but certainly going through this section 1.3 is important. I think I even say it in chapter 10. And then really you can jump ahead to chapter 10. You've taken 520, so If you wanted a refresher on just deep learning in general, what you could do is you could read through chapter 4, but basically if you've taken 520, this would not be necessary. And then you can just really jump ahead to chapter 10, which is, should be here somewhere. Oh, here. So this is the, this is a write-up I did on the original paper, the 2017 Vaswani Attention is All You Need paper. So you can, if you really want to understand all the details, read through this. I don't expect you to really understand every single detail. This is 100 pages, and it's, like I said, it's pretty complex. But it's the encoder decoder with multi-head attention, the original transformer, not the variants like these that you see here. So you can go through it. These are the things that I explained in class, right? So the transformer and the model, an overview of the flow of the information, the main ideas, right? In transformers, things that we've talked about, like encoding, right? Now, this chapter actually includes two things. So if you notice, whenever we use transformers, the transformers module from Hugging Face, we always take a pre-trained model and we have to download both the tokenizer and the model itself. So we always download two things, okay? Well, this chapter is actually also made up of two parts, the part for the tokenizer, the data loader, if you will, and the part for the model itself, okay? I usually call that part, the tokenizer or the data loader, the data wrangling section, okay? So I wrote that part from scratch to really understand everything that's going on in there, so you can take a look at that. And then there's the modeling part of the transformer itself, right? So first I laid out some ideas like what masks do and teacher forcing. So read through all of that. The attention mechanism, I in particular explained that, positional encoding. You can take a look at that, work through the exercises. So that might be of use to you. And then I describe the code. So I go into all the details of it. Data wrangling, as I said, would be the section on the data loader and the tokenizers themselves. And so that part is pretty extensive. So you can read through it, but hopefully it'll make more sense. And then here is the architecture of the transformer model itself. Should be, yeah, so I think this is still the processing. So then the encoder should begin here, the architecture, right? So now it starts going into the details of the encoders, the decoders, which is things that I covered in the videos previously, as I said, in a high overview. There's too many details, but I have tried as much as I could to represent everything with the math operations that would take place on the tensors. Okay, and so you can read through the whole section here, right? Oh, the encoder, the decoder architecture, all the parameters. Okay, you can see it's pretty extensive, but the dimensions should be correct. If you spot any mistakes, just let me know. You can see here, right? This is the finalized architecture. Okay. You see, it's pretty extensive. So it's very difficult to really go into all the details, in a lecture. And I think it's probably just better to just kind of read through it. All right. And then, it's got some examples of how it works, running through some training and testing examples. So you can see. And that's it. All right, so what do I expect from you for this chapter? I don't expect you to memorize this or really, just read through it. That's kind of, take it as reading this from now until the end of the semester. It's your reading assignment. This is a graduate level course. It's pretty advanced, right? So, and we're doing some pretty complex things. Now, will you ever have to implement the transformers from scratch? Well, as you can see, according to Huggin Face, we should not, right? So Huggin Face has tried to abstract as much as possible. And hopefully, if anything, by me giving you this 100 and so pages of the description of the transformer, you will understand that it's a very difficult and complex thing to implement from scratch. And so it's probably better to try to use the transformers as best as we can. And in particular, because the other reason is, of course, remember that we don't have all the data that Google and OpenAI have, so we would never be able to create pre-trained transformers that are as good as theirs anyway, okay? But it's good to also understand how the algorithm works as much as possible. And then I'll let you guys read through this for a couple of weeks. And then, after a couple of weeks, we can go back and kind of discuss if you have any questions about anything or anything like that. How does that sound?
Sounds good.
Sounds good, right? All right, good. So I think that's the best approach. As I said, if anything, the one thing I might do is in a very high overview, I may go over the other ones. Like, okay, so how is BERT different from this original one? How is Roberta different? How is GPT-2, GPT-3? In essence, what I can tell you right now, whereas in the multi-head attention, we have in the multi-head, in this one, where is it? Give me a sec. Whereas in this one, the original one, looking for that graphic. Oh, here. Whereas in the original one, we have an encoder and a decoder layer, right? So this one, if you notice, the inputs come here, they go through the encoder, they produce the encoder output, and then the encoder output becomes input to the decoder part. So this, yeah, these are all encoder layers within the encoder. These are decoder layers. So this was the original one used for language translation. The example that I use for this description is also for language translation. My understanding is that BERT only uses the encoder part, whereas GPT-2 and GPT-3 use both encoder and decoder. Okay, so, but these are things that we're gonna be discussing a little bit more later in the semester. All right, anyway, I wanted to point this out, this document. Are there any questions about it before I move on? Have you guys started reading this chapter?
Yeah.
All right. And no comments or questions so far?
Not yet.
Yeah. All right, great. All right. So anyway, that's your reading assignment for the semester, basically. All right. So now that we've talked a little bit about that, let's now go back to the whiteboard. And so we've addressed, so that's the theory, but this is a transfer learning class, so we're going to be focusing more on most applications today, right? So that's really what I want to talk about, how we can apply transformers. And then we're going to get into some code. I have one specific piece of code that I want to take a look at today. But I feel that for us to get a better understanding of the different applications of transformers, we should start with a problem, okay? And so this is going to be the problem for the term project. So the transformer term project. The transformer term project. Okay. All right, so what is the problem? Obviously, it's going to be, although, you know, we still want to talk a little bit about vision towards the end of the semester, this is all NLP. So our data is text. It's going to be text. Okay. Today, we're going to use a little data set that I'll show you to do pre-training, right? So we know that we're going to use a pre-trained model. So that's something we know. So we're not going to train from scratch. That's not something that I want you to do for the project. Instead, use a pre-train, but then we're going to fine tune with our data. And then we're going to solve a problem. Basically, this is the approach that we want to take, okay? So when you talk about transfer learning, there's several things. There's something called zero shot. Zero shot. There's something called few shot. And then there's, of course, fine-tune with your data. So zero shot just means you don't have any additional data. You just use the original transformer and you adapt it somehow, but without doing any training. Do you guys see that? So that's kind of the example of what you guys were doing with the bias problem, right? Where we took, in the bias problem, we took just Alberta and we modified them, but we didn't do any training. We tried, that's kind of zero shot, right? We didn't give it any additional components to learn. In few shot, we would do, so in few shot, we would do a little bit. We would give it a few examples of what we're trying to do, and then it would learn a little bit. And then with fine tune, we would be expected just to have more data. Do you guys see that? All right, so for our approach, you can try all three, but in particular, the one that I'll be looking for is fine tuning, okay, that you pick one. So you're gonna have to make the decision as to which model you use, whether you use the original, whether you use BERT, Roberta, Albert, BART, GPT-2, etc. Okay, so you'll use one of the established transformer models from the Hugging Face hub. Then you're going to fine tune with some data, but the data has to be in such a way that it solves the problem. Okay. So the simplest example that we can think of right now is, for instance, let's say that we want to, we have some sentences, sentence 1, sentence 2, sentence 3, right? And we want to predict a class for it. So let's say we have 3 classes, and they are sport, they are science, they are, what else? What's the third? Sports, science, fiction, let's say, fiction. Right, so we want to determine if, you know, given an input, what it is, right? So we could build, certainly you guys know how to build a classifier, right? You take the bag of words approach, for instance, you take the sentences, and then you have a training set with these labels, and you kind of build a classifier like that. However, with a transformer, the advantage is that if we use a pre-trained transformer like BERT, etc., it's almost, you can almost argue, you can make the argument that they already speak English. Whereas with the one-hot encoding, etc., you have to train everything from zero, right? But here with a transformer, let's just say BERT, right? You now have, it's already pre-trained. So it already knows the words, right? So it's got a tokenizer and it's got a model. So it already knows how to do something with that. And then what we need to do is we're going to have a corpus of examples of sentences, right? And their associated classes. So that's the most simple way of understanding this. Okay, so the first step is we get, a pre-trained BERT model and tokenizer. Okay, and then we're going to we get the data set, where in the data set we have a data set with the following format: class, text, class, text, class, text. Okay, dot, dot, dot. All right, so if we have our data set like this, and our objective is, given some input sentence n, which class is it? Predict the class, right? So, which class is it going to be? So we already know that all we need is the pre-trained model. We know the data set, but now we're going to need one additional thing. The third thing is we're going to need a specific module from the specific function or module from the transformers library that has already been designed for that. That is to say, we need a specific from transformers we need basically, let's say, a BERT. Oops. We need a, because we've chosen BERT, right? So we need a BERT model, a BERT module, but for this specific application. Do you guys see that? So that's why I said one of the things that we're going to talk about today is applications of transformers. Okay, I will kind of list out some of the things that you can actually do with transformers. And really, these things that you can do with transformers are the things that people have been doing with NLP for years. So for instance, you guys have already done, you've actually used this for sentiment analysis, right? So you did a little bit of sentiment analysis at the beginning of the semester when you were doing the bias testing. And so, the ethics testing. So then here we have from transformers, we pick a model BERT, but there are several. It's almost like there's going to be a library of BERT and specific application. BERT and specific application. Okay, so that's the idea. So we need to know which type of BERT application we need. And we're going to choose that one. Then we're going to download the pre-trained models for that particular task. And then we're going to provide our data set in the format that it needs to be. Does that make sense, guys? That's an important idea. Are there any questions about that? No questions? That makes sense?
Yeah.
All right. All right. So yeah, so that's basically then your term project is going to be that. Right. So today's example will be this particular scenario that I just ran. So we're going to pick, I want to classify sentences as belonging to some categories. So I'm going to put the data in a specific format, and then I'm going to pick a model, and then I'm going to I need to specifically choose the one that is for classification, okay? And so that's one of the things I'll note today. All right, So anyway, so this would be the simplest example I can give you, right? So this is an example of the pipeline, if you will. However, now we're going to motivate a little bit more what the problem is, because your solution to this might be this, right? It could be like this, or it might be different. That's the whole point of the project. The project is difficult because of this, right? If the project was just this, you'd literally have the code. So I'm making it a little bit more interesting by trying to give you a classic example of something people always want to do in machine learning, okay? And NLP in particular. So now let's think about the problem. And to be honest, I picked something that I don't necessarily have a solution for. Okay. Now I'm sure, whenever you think, oh yeah, I have a very novel problem, I guarantee you several people have already solved it all over the world. So one thing that I would recommend for this is, number one, check the internet. Okay, check the internet to see what others have done in this on the internet by looking at websites, blogs, and also obviously research papers. Now, I am not in any way asking you to write code from scratch, okay? All of what you do should be based on the transformers module, maybe modified a little bit. Certainly here, you might need to do a lot of work in getting the data set to be in the specific format, but I'm not really asking you to do things from scratch. I'm really just find the best model probably that would solve your problem. Okay, so the approach to this problem should be like this, right? So read websites, blogs, research papers, see what others have done, okay? And then you will apply, once you have figure out a methodology, and data using the transformers, so using Hugging Face transformers module, okay? So just use that. And then you're gonna, basically train and test, fine tune, let's say. So then you're gonna fine tune and evaluate. And then you're gonna report your results and tell me if you think that you did well, or if you don't think you did well. You can also, the data set, you can annotate it a little bit. So that's something that is certainly a possibility. All right, so now, what is the problem? So the problem is like the classic example in science, right? Or in text. You have some paragraph. Let's say you have a paragraph. And then you have a set of categories over here. So you have a set of categories. And you can have many categories, not just a few classes, but many categories. And then, so for instance, what's, one example that would be pretty good here is like in biology. Think of biology as an example, right? In biology, what do you have? You have a lot of plants, or you have a lot of birds, or you have a lot of insects. Let's take insects, actually. That's probably a good one. So you have a lot of insects. Would you agree that the insects are probably classified? There might be millions of insects, right? Of different kinds of insects, but these insects can be classified into groups, correct? Do you guys see where I'm going? So the classification of those insects is kind of what you want. So you would want to find, some text here that maybe talks about insects of some kind, and then it's going to tell you what category they belong to. Do you guys see that? Does this make sense?
Yes.
So this is the problem. So, or in like genetics, right? Genetics might be another place where you have like proteins, or you have cells, or you have all kinds of things in text, right? Just a lot of text that has been written. Maybe you're getting all the research papers, right, that are in PubMed, you know, related to science, to medicine, to genetics, right? You get all those papers, and then you have a list of categories. And now you would want to say, well, this paragraph, just by looking at the structure of it, I believe it relates to this category. I can make the connection, right? And it might be that these categories also have associated text with them. So it doesn't necessarily need to be like just a category, but it could be a category with some additional text. So at the end of the day, the problem is a mapping problem of larger text to smaller text, but where this text is actually some kind of a category. Do you guys see the problem? Is this understandable? So the question is, what is this? What would you guys say this is? Just if we discuss it, what type of a problem would this be?
This classification? Or?
Yeah, maybe. I mean, maybe. The thing is, we got to think about how we're going to train the transform, how we're going to fine tune, right? So how do we fine tune? How do we fine tune the transformer? Okay, that's the key thing. So today I'll definitely give you an example of classification. Okay, now the data set that you use, that's entirely up to you. I can also probably provide a data set for you guys to use, or you can just find your own. I kind of leave it to you. I don't like giving students like specific things, because I kind of want you to be motivated sometimes, but I could also do that. Just provide a data set. All right. So anyway, this is the problem statement that you need to solve. Questions about the problem statement? So is the project clear now?
I think so.
I think so. Okay. All right. All right. So yeah, that's the idea. Okay. All right. So now I've given you kind of the motivation of your project. Remember, this is your semester project. You have until the end of the semester to solve it. And one thing that will be critical for this is actually having more discussions about it, right? So definitely start working on it, start thinking. All right, so now the next thing that we're gonna do today is we're gonna look at all the different problems that can be addressed with a transformer model, all right, just for NLP. So that's the next part of this. So certainly we've looked at sentiment classification. Right, so we've looked at sentiment classification. That's one problem that we have looked at. Today, we're going to look, as I said, one of the examples that we're going to look at will be just category classification. That's basically the example that I kind of want to go through. And and it's one that you should actually implement. All right. So these are two examples of so these are applications or applications of transformers. Right? In NLP. All right, so some of the classifications are, so we've got for text classification, right? So we have, and these are mainly based on BERT. So we had the one that you've used already, which is mask prediction. Right, mask prediction. We have single sentence classification, which is kind of these, okay? Then we have something called sentence pair regression. Which really, as the name implies, the idea is that this would try to compare basically two sentences. You have two sentences and you kind of want to compare them. So you do like a regression so that you can calculate, let's say, a similarity. Okay, so that's another approach. So you can do regression. Now remember, for all of these from transformers, you're going to need a specific application module, okay, for the type of solution you're trying to implement. So these are mainly like single classification, right? Like the standard classification. Other applications of transformers are what are called the token classification. And what this means is these are basically when you have sequences of text. So these apply to sequences of text. Okay, sequences of text. And so you're going to predict the label, but for every token in the sequence. So classic examples of this are named entity recognition and part of speech tagging. And also, another one is going to be question and answer. Okay, so these are the token classification modules. So do you guys know what I mean by this? Anyone know what named entity recognition is? Could you give me like a description, maybe? All right, so named entity recognition means, for instance, did you want to say something?
Yeah, it took me a minute to get the mute button. Like identifying people or organizations.
Exactly. So as if you notice, they're different, right? Whereas here we give it one single sentence and it predicts the class, or we give it a sentence with a mask and it predicts the word. In token classification approaches, it's a little bit different. We've got these three that I'll talk about by providing examples of them. Named entity recognition, part of speech tagging, question and answering. Okay, so again, the idea is you train a BERT model, right? So it's got, it's learned the language. Then after that, you need to use a specific transformer module from Hugging Face for token classifications, token sequence classification, right? So it needs to be trained specifically for that. So you need the specific model, the data set needs to be in the specific format. But in a high level, the way it works is you have, for instance, you know, the author John Smith is driving to New York. Okay, so that's your input to the model, an actual sentence. The output of this should be where the named entities are located. So for instance, usually you use, in named entity recognition, you have a standard set of 9 tags. Okay, 9 tags, which basically one of them just indicates that it's not a named entity, and then the other 8 have to do with proper name, name of a, or as you said, location, etc. Right? So in this case, let's say here it would mark this. So first of all, let's break it up into tokens, right? Imagine it's some kind of a list. So now if it's a list like this, then the output for this would be, oh, let's say author, you know, is that a name? Is that an entity? Would you guys say the author, John Smith? Would author be an entity? Yes or no?
Yes.
Yes. All right. So then we would mark it as person, and then John, definitely person. And then Smith, person. This is not a person. This is not a person. Not a person. And then this would be location. So it would probably be location, location. Do you see that? This is something that transformers can do, and there's a module for it. Okay. Any questions about that idea? Usually the standard data set for this is called a con-LL. So a lot of the, whenever you're doing training or fine tuning, you can use the con-LL module for this. Okay. Now, when you're doing this type of problem, the Hugging Face module for BERT is going to, so the command will be something like from transformers import, and you're going to need the auto model for token classification. Right? This is the specific module, if you will, in transformers that will permit you to do something like this. Okay. If we go back to the previous one, for the other classifiers, if we look at the common theme, let's see here. For the standard sentiment analysis, category classification, etc., we can use sequence classification, right? So there's something called, whereas this one is for token classification, we have here for this one from transformers import, let's say BERT for sequence classification. So you see the difference, right? So for sequence classification, versus for token classification. All right, and this is how, now this is an entirely a construct of the Hugging Face team, but it does make our lives easier, basically, to do that. So we've got here, yeah, for sequence classification, we can apply that to a lot of those problems. Yeah, I'm just making sure. Yeah, for sequence classification would be for a lot of the problems. Right, so if we go, actually, we can go to my GitHub right now. Let's just go to the GitHub. All right. So you guys should be seeing the GitHub. If we go to the repositories, if we go to transfer learning, in this Hugging Face transformers fine tuning, most of the algorithms I have in here are all for sequence classification. So if we click on this one, you will see if we look here, BERT for sequence classification, BERT for sequence classification, right? That's being used for that. Here, if we look, BERT for sequence classification might be distill BERT, but it's still sequence classification. So that seems to be the module that we use whenever we just want to give it a sentence and then say like the sentiment, etc. This one too, here you can see for distill BERT for sequence classification. You can see all of these are that basic idea. So that was regression. We click on this one. Again, this BERT for sequence classification. And then the tokenizer obviously has to be the matching tokenizer that's appropriate. For sequence classification. These are all for that approach. Here we've got auto model for sequence classification, various different variants, but they always end with for sequence classification. And sequence classification here. So as you can see, a lot of them, basically all the examples I have in this repository in fine tuning are just for sequence classification, okay? All right, so hopefully that's clear. Now we can go back then to the whiteboard. And as I said, so the first set is, now you have at least a set of tools, right? If you're gonna do like a standard classification of your problem, maybe look at for sequence classification. But what if you think of the problem as token classification? Well, in that case, the problems that you might want to address are like named entity recognition, part of speech tagging, or question and answer. So in named entity recognition, we use the auto model for token classification, okay? And as I gave the example, that's what happens. The input is this, and then this should be the output. Make sense? Any questions so far? All right, I'm not hearing any questions. So let's look at the next example, which is for part of speech tagging. Part of speech tagging is actually pretty much the same as named entity recognition. It's usually pause, part of speech tagging. So the same idea. The cat is eating, right? So we would, break it up into tokens, and then we would assign now the part of speech tag. So in this case, this is a determiner. This is a noun. This is what? Verb, adverb, etc. Right? So these are the terms that would get assigned to these words in the sentence. Is this clear, guys? Is this clear, guys?
Yeah.
All right, great. So again, how does this work? We take an original BERT, just pre-trained. Then we add the token sequence training. Oops. And then we, basically predict. Lucky for us, these are also built in, right? So we have already built in models from the Hugging Face repository. That's another thing to remember, is that you can just use, let's say that you guys did a project, solved it, and now you would upload the models to Hugging Face. So the model is already ready for you to use, okay? So that's another pretty important aspect of this. But I'm just kind of showing you right now some of the applications. So named entity, so if we go back, named entity recognition, part of speech tagging, and then we have the last one, question and answering, which is a little bit more tricky to understand. Question and answer. Okay, so this one's a little bit more tricky to understand because it's not really as intuitive, but the way that it works is usually like this. You have a question, which is a shorter sentence. Question, right? Which is, it's a short sentence, and then you have a paragraph. No, that's not the answer necessarily, but it's you have a paragraph. And within this paragraph, what you have to do is you have to indicate what part of it is the answer. Do you guys see that? So what we can do is if we take this and make it into a long string, then you would say, for instance, that the answer is located here. So it's almost in terms of marking this as a sequence, you could think of it as, let's say, no answer, no answer, 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 no answer, no answer, no answer, no answer. So you break the input into chunks. So in that sense, it becomes similar, right? So you give the input, this is the output, but this is dependent on having a short sentence for the question. And this is usually the most famous approach to this one, which uses a data set called SQUAD. So whereas named entity recognition used ConLL, the most famous for question and answering is a data set called SQUAD. Okay, but this is the idea that you would mark, you have basically here the elements of a paragraph where the answer will be contained. You have a question and you just have to indicate where the answer is located. Now for these three, if we look carefully, so for these three, we're going to invoke so for these three, we're going to have to invoke the auto model for token classification. Right, so here it is, auto model for token classification, which is the particular Hugging Face module that helps us to train for this type of problem. So anything, so there's going to be variants like data collator for token classification, but they're all going to end with for token classification. Could be an auto model for token classification. Now for the question answering one, because it's a little bit different, that's the one I was looking for here. That one uses a slightly different module from Hugging Face. So let's say here, question and answering. This one does have its own, so it's going to be from transformers. From transformers, import auto model for question answering. Okay, for question answering. Usually what these, like in this scenario, what this returns is actually it treats the string as a buffer, let's say from 0 to 150, for instance, and then it's gonna find the answer at position 75 to, let's say, 95. So the answer is going to be that it's gonna say the answer is located at 75 to 95. So just be aware of that, okay? That's one way that it likes to answer the question. I think it can also output like a list like this, but you just have to play with the Hugging Face module. So that's a little bit specific to that. But as I said, for the question answering, you're using now this approach over here. Okay. Does all of this make sense so far, guys?
Yeah.
Yeah. All right. Okay. So that's basically that's basically the set of applications that we have for natural language processing with transformers. So we've got token sequences, question answering, part of speech tagging, named entity recognition, or we have the standard, assign a class given a sentence input. Okay. So let's look at the time. So it's 3:50. Let's take a 10-minute break. I'll generate this video, and then in the second half of the class today, we'll just continue with this and also get into the code, in particular, the specific code that I have on the GitHub for category classification. All right, so we'll go over that code so that you have an additional example. Sound good?
Yep.
All right, yeah,
Yep.
so let's take a 10-minute break and we'll continue at 4 o'clock.